Well, thank you, Elizabeth. Thank you, everybody. It's a real privilege to be here tonight. I had the privilege of speaking last November on the topic of failure analysis, and so we decided to change things up, bring up a topic that I think is near and dear to many of us, regardless of the industry you are in, and that has to do with counterfeits. Now, this is a solemn day when we're remembering what happened 11 years ago on 9/11. And how that shook our world, how we became aware of how our security could be threatened unexpectedly. Now, our livelihoods can be impacted by a number of things, even economically. So there are things such as industrial espionage, economic espionage, and I would propose that counterfeits are a way in which our economic well-being can be undermined and attacked. So this is a topic that is perhaps apropos for a day such as today. So, but thank you everyone for what you do in the quality world. And what I want to do is affirm that what you do as quality professionals is very important indeed. And as we go through these slides, I would just challenge you to consider your role in your organization and the impact that it has on the security of your company that you work for, as well as the security of the economy and the well-being of the economy as well. So let's move on. And hopefully everybody has a copy of our brochure and my business card. We have contact information on those pieces of literature. Also, you were handed out a questionnaire. If there's any other topic that might be of relevance to you, either as a future presentation or if you need to contact me for additional information, if you could be so kind as to provide whatever area of interest you have, as well as your contact information. There is a box over on the table in the back of the room, as well as additional literature. So, and feel free to take advantage of that table. So here's a brief index of what we'll cover, but the heart of the presentation is really going to be on counterfeits. And then as we have time, I want to open the discussion up to failure analysis and any questions that you may have. This is really your time, your opportunity to ask me the toughest questions you can related to component failures, component quality issues, you name it, counterfeits. This is your session, and I want you to feel free to have that interchange and that interaction with me as a speaker. So let's talk about the impact of counterfeit goods. As quality professionals, we love data, and we love hard, quantifiable data. Nick, what is the threat to our economy? How big of a problem is this? Well, this is a bet. Let me start off by saying there's limited data available that would very precisely quantify the problem. And the reason is we only catch some of the bad guys, some of the people who are bringing counterfeit goods into the United States. And so what we have here is we have a chart put out by Homeland Security. And this chart shows that at certain international points of entry, there has been counterfeit goods confiscated, seized at those ports of entry. And the different topics, or the different, my laser pointer isn't working so well. Anyway, on the x-axis, we have different types of goods that have been seized, varying from electronics to commercial goods. For those of you who are in the pharmaceutical industry, of key interest will be the pharmaceuticals that are seized. And pharmaceuticals are a big issue, as well as our electronics, consumer electronics, any sort of electronics you can imagine, even those sorts of electronics that are involved with medical and safety. And if you were to add everything up, there is about $1 billion worth of goods, over $1 billion worth of goods that are confiscated in any annual period. So If we break it down in terms of the confiscated goods that are of concern to health and safety and livelihood, pharmaceuticals would rise right to the top, electrical articles are next, and then you get into some of the personal care items, etc. And critical technology components, that's what we're going to focus on in more detail as we go into the presentation. But this is quite a spread of technologies and industries that are represented here. So each $1 billion or hundreds of millions of dollars of confiscated goods perhaps represent 50 to 100 times that amount that actually make it into the economy and affect our livelihood and our security and our health. Now, there are some widely published pieces of data that will state that this is a $200 to $250 billion hit on the economy per year. And as I explored that data and tried to find the actual source data that fed that FBI press release, what came up was that there was actually no source data to back up that claim. So that was a little bit concerning, and so I just wanted, in full disclosure to you, to let you know that there is not hard data that supports $250 billion a year hit to the economy, but rather that is an extrapolation, and that is a best guess based on seized goods. So that claim has been disputed in terms of a reliable data point. Now, the OECD model, which is the Organization for Economic Cooperation and Development, that's an international group that has looked at the scope and the breadth of the counterfeit problem. They have used a model that is really, it uses several different sources of data, and they estimate that it is probably, on a global basis, roughly a $200 to $250 billion a year issue. So globally, it could hit that $200 billion to $250 billion a year. That is a lot of money. That is having a significant impact on the overall world economy. And then if you look at the United States as the largest economy in the world, you could say, my goodness, we are probably the lion's share of that $250 billion estimated impact. So that helps us get our arms around how big of a problem is this, just from an economic perspective. However, it goes beyond the economic impact. It really starts getting into loss of life, health, and property, where it's very difficult to put a dollar figure on somebody's health. It's very difficult to put a dollar figure on somebody's life and your security and your peace of mind. So counterfeit pharmaceuticals, you may have a counterfeit pill that may have zero efficacy. And so you may have an AIDS patient, you may have a cancer patient who is counting on the efficacy of that medicine, and there's really no active ingredient, okay? So that is one possibility. The other possibility is that that counterfeit pill or pharmaceutical agent actually is poisonous. It could be a different medicine, or it could be no medicine, but perhaps a filler that is actually poisonous to that person's system. So, you could have lack of efficacy, you could have a poisonous reaction. Cosmetics and personal care items, I skipped over counterfeit aerospace components. So on any aircraft, you have many pneumatic actuators, you have switches, you have indicator lamps, you have a number of electronics, mechanical, electromechanical, pneumatical components that could be counterfeits. And how many of those counterfeit items are mission critical components? You need that component to work in order to land safely, take off safely, stay in flight. Cosmetics and personal care could be counterfeits of those products, could be actually very toxic to the user. Maybe not immediate, but perhaps over a long-term use. And then smoke alarms, anything related to safety or health. Those could be counterfeited items that will not stand up to the rigors of use or perhaps fail their intended use or mission. Communication devices, industrial controls, safety equipment, a number of things. So if we think about how counterfeit components can impact the ability of those end items to actually serve their purpose, the consequences of counterfeits making their way into those end items, it is devastating, absolutely devastating. Now, what is near and dear to my heart as an employee of a defense contractor is national defense and security risk. These are all very important to me, but because of my livelihood, because of what I see every day in the job place, national defense and security is a big deal, and we'll get into that in some of the special legislation that has come about to address this industry sector. Okay, counterfeit electronic components entering into the DoD, Department of Defense supply chain undetected. That is a very bad thing for defense contractors. It's a very bad thing for our fighting men and women. And that's what we're going to get into in the next slides. Any questions at this point in time?
Notice there was no automotive on there. Quite a bit of automotive coming.
Right, and I would put that right in with safety equipment and everything else. But you're right, automotive belongs up in there as well. If you have an under the hood electronic assembly or mechanical assembly that fails because of a counterfeit part, I mean, that could cause a crash. It could cause a single mother with 4 kids traveling home in the middle of a winter night. She may not get home that night. Okay? Thank you. So now we're going to discuss some of the legislation aimed at addressing the risk of counterfeits entering into the Department of Defense supply chain. So anything related to the defense industry. So the 2012 National Defense Authorization Act was aimed at addressing the risk of counterfeits. Okay, and it was Senator Carl Levin and John McCain who authored the H.R. 1540 bill. And we do expect revision of that bill September 26. So defense contractors were given an early glimpse of that legislation. Was it early this year? Late last year? Early this year. And so there were some things that were a little bit uncertain, and we'll talk about that. So that is of utmost importance to defense contractors, and I think we have a few defense contractor employees in the audience. Right, thank you. So September 26th is the expected revision date, and the most anticipated point of clarification is what is a trusted supplier and what exactly is an electronic component. Okay, so right now, something as what seems as straightforward as a trusted supplier, not exactly clear. And you're going to hear terms such as original component manufacturer, or OCM, and authorized distributor. So in the supply chain for electronic components for defense contractors, the original component manufacturer and authorized distributors are considered at the pinnacle of the supply chain, and they are considered the most trusted of suppliers because the authorized distributor should have a legal binding relationship with the OCM that says, hey, you can only sell bona fide new components from me if you represent me as an authorized distributor. And the original component manufacturer should only sell new, genuine parts. He should not be selling used parts. So those in the defense industry consider those as trusted suppliers. But then we get into other areas where it becomes a little bit more gray, and we're looking for greater clarification, such as when you cannot, when you are in a situation where you have a legacy program, a defense article that you've been manufacturing for the Department of Defense for some period of time, and the DoD wants you to continue producing that old design, you soon run into an obsolescence issue, a component obsolescence issue, where it's more and more difficult to find new components of that particular part number and vintage and what have you. It becomes very difficult to find that within the supply chain through the original component manufacturer or authorized distributors. So then you have to start searching the four corners of the earth for somebody who has that either in surplus, or there are other possibilities, okay? And that's where brokers, non-authorized distributors come into play, and we'll talk about that a little bit later. Let's move on. Ultimately, the defense contractor has the liability, okay? The Department of Defense has told the defense contractors, you are responsible. If there are any escapes, if you introduce a counterfeit component into your end item, you are liable. And the DoD says, if that enters into your end item and you detect it after the fact, don't come to us for additional money to rework and to get that obsolete component out of that end item. It is on you. You have the liability. You have to make it right. So we're going to talk about some of the strategies that we as defense contractors enter into. And hopefully a lot of these strategies will also pay off and make sense and be applicable for non-defense related companies. So all tiers within the defense supply chain are to apply preference for procurement from the OCM or its authorized distributor. So those are the marching orders. Whenever you can, purchase your parts from the OCM or authorized distributor. And when they're no longer available, they must be obtained from trusted suppliers. Again, we're waiting on further clarification on that. And if it's not possible to obtain through the OCM or authorized distributor, we need to contact the Department of Defense, and we need to make sure that we have enough countermeasures in place to then make sure that those components that are not procured through the OCM or authorized distributor, to make sure that they are absolutely not counterfeit components. So what we've done, that's a tall order, because prior to this awareness of the depth of the problem of counterfeits, many defense contractors did not have a rigorous counterfeit component prevention and detection system in place. So that has set off a number of countermeasures and developing internal systems to prevent counterfeits from ever entering into the manufacturing place, into the supply chain, and eventually into the end item. So Guide-Up system is a information sharing system amongst defense contractors and different government agencies. So if we become aware of a problem broker, we can report that through the Guide-Up system. That is a nice way to share information. And this legislation requires us to share information. So that's one of the positive things about the legislation, one of the many positive things. Okay.
Access to that limited to DoD suppliers?
That's a great question. I believe it is limited. Well, to what degree is it limited, I can't say. It could be limited based on, well, I hate to speculate. So I do not know the answer to that question. Okay, is there anybody in the audience who does know the answer definitively? Okay, great. Okay, thank you. Okay, and the Homeland Security and Customs and Border Protection, they have enhanced inspection powers, specifically because, well, primarily because of this counterfeit component issue. So everybody is stepping up their game. And as I mentioned before, this bill is not, or this law is not a finished body of legislation. We expect an update September 26th. That is the date that the government has put out. It's possible that that date may come and go, and they'll revise that due date. So. Okay, now, and one of the things that we're a little bit unsure of is, are they going to expand this legislation to also cover mechanical components? Presently, it is silent on mechanical components such as fasteners and things like that. So that it'll be interesting to see if it becomes more all-encompassing. As far as penalties go, if you are caught trafficking in counterfeit electronics, counterfeit components, big-time, multi-million-dollar penalties and prison terms. Now, one of the challenges for defense contractors is, when we're in the throes of trying to determine is a component a counterfeit or not, we are not, or the OCM is not required by law to give us absolute support in that endeavor. So that's what we get through our interpretation of Section 818. And also, from an obsolescence perspective, the OCM is not under obligation to continue a line of production on a critical component necessarily, even though that is a critical component in our defense article that we manufacture for the DoD. And strictness of the language in the legislation makes it absolutely clear that defense contractors establish policies and procedures to eliminate counterfeit components. Okay? And it's not a best practices effort, it is zero tolerance, for counterfeits. Now again, the vagueness of the language, as I mentioned before, exactly what is an electronic component. We're concerned that that could be expanded into anything that passes electrons. It could be a piece of wire, it could be a standoff, it could be a metal fastener that happens to be in the ground loop of that particular piece of equipment. Okay, any questions? Okay, so how do we deal with this? We're going to talk about an organizational approach to dealing with counterfeit components. And really, what we recommend is heightened procurement activity or heightened supply chain control. Ultimately, this is an organization-wide effort. It involves engineering, quality, component engineering, manufacturing engineering, everybody. But in procurement or supply chain, there are a lot of requirements that can be passed down to the suppliers. There are gates that can be put up in the supply chain so that things are quarantined before they're ever allowed through that gate, so that we can make absolutely sure that counterfeits are at least, or we can examine in greater detail whether a supplier who is not an OCM or an authorized distributor, we can examine those components and make sure, absolutely sure they are not counterfeits. So, following good procedures and disciplines for procurement will help reduce risk. I said reduce risk, not eliminate it, because the counterfeiters are very, very deceptive and very effective at times. So you will see a broad spectrum of counterfeiters in terms of their ability to deceive the procurement activity. And when these circumstances require purchasing through someone other than an OCM or authorized distributor, we have to deploy effective counterfeit component detection methodologies. So we went from counterfeit avoidance to really counterfeit detection. So the best way to avoid counterfeits is to only purchase through OCMs and authorized distributors. But when circumstances prevent that, Now you need to deploy countermeasures, and we're going to get into those countermeasures in just a minute. So if you have to go through a broker, through a non-OCM and authorized distributor, you need to be very, very selective. And we recommend that you establish some very, very trusted brokers that have effective counterfeit detection internal to their organization, highly trained people, and have a formal vetting process for non-OCMs and authorized distributors. So that would be an internal vetting process. What are you looking for in your distributors or your brokers? In an emergency situation when the parts are not able to be obtained through a trusted supplier, subject those parts to a very thorough counterfeit detection inspection with a trusted internal or independent lab. Okay? And DoD notification is required based on our interpretation of this legislation. We have some folks in incoming inspection or receiving inspection. Receiving inspection is a great place to review the paperwork, require full traceability back to the OCM. That is a minimal amount of detection that you should be performing. And define and implement an in-house inspection, detection, quarantine, and reporting/documentation policy. So it's now's the time to get prepared. Now's the time to get ready. So that is the organizational way to prevent counterfeits from entering into your supply chain. Now we're going to talk about some lab practices. We're going to talk about countermeasures that you deploy when it's time to, when you're encountered with the necessity to go through a non-trusted source or a broker or someone that they're the only people in the world that have the parts you need. Well, now how do you know whether those are counterfeit parts or not? Well, there are lab practices and analytical approaches for detecting counterfeits, and that's what we're going to talk about now. First of all, let's talk about some of the techniques used by the electronic component counterfeiters. These techniques for getting the materials that they will then try to sell on the gray market, it can involve very, very crude methods, such as holding a scrap circuit board. A lot of our surplus electronics, scrap electronics, are shipped in container ships, and they go over to developing countries, to Asia, different places around the world. Even domestically, I've heard that this happens. And the circuit boards are heated up to a temperature in which the solder joints will reflow. And then the circuit board is struck against a hard surface and the components fall off. Okay, that's a very crude method. And then the counterfeiters go through a sorting process where they sort by component package type or part type and what have you. And perhaps those reclaimed parts then go to the next tier in the counterfeiting organization, where now someone may take those parts and relabel them, remark them, do what is called a blacktop operation, where they essentially cover over the original markings and mark them with a new marking. It could be to give it a newer date code, perhaps a different supplier marking, you name it. Sometimes they grind the surface prior to applying the blacktop. So, replating of leads, reballing of ball grid array devices, anything they can do to make the part look new, look presentable, and pass as a quote-unquote new part. Sometimes dummy parts are manufactured, so the package of the device will look legitimate, it'll look brand new, but there is no active device inside of the package. So that happens as well. And the active device, that's where much of the value of the component is. And guess who the common target is for these counterfeiters? It's many times it is a defense contractor who has a legacy program, a program that has gone on in the life cycle to a point in which it's very difficult to procure those older technology parts from the original component manufacturer or an authorized distributor. So there's a lot, it's a very lucrative, deceptive practice, but many times the obsolete parts will sell for a premium on the gray market. And so it is quite a lucrative business for these counterfeiters to engage in. Any questions? Great. If you were to ask me, well, Nick, I really need to set up a counterfeit detection program, or I need to hire a counterfeit detection lab, what sort of inspection should we be doing? And the answer to your question is it depends. Now, how do you like that for a definitive answer? Sorry, guys. But anyway, a lot of it depends on the level of scrutiny and assurance you and your contract require. But there are some basic minimum steps that any lab should be doing, or any internal detection program should be doing, and that includes high and low mag optical inspection. And just a good optical microscope can be very effective looking for evidence of tampering, such as, you know, are the leads straight? Do the leads look like they've been bent and then re-straightened? Does it look like that the solder on the leads is from a prior assembly, or does it look like an as-plated, brand new IC? Is there evidence of black topping? Okay, because many times the finish of a blacktop surface is much different than the rest of the component body. So these are visual clues that can be detected with a good optical microscope inspection. Looking at the markings, okay, comparing those markings to a known good part from the same vendor. If there's a difference in the logo or a difference in the marking scheme, that should send up a red flag. Okay, if the quality of the marking is an issue, that should send up a red flag. So just good detective work and perceptiveness on the part of the inspector. And a lot of this takes training, takes experience. Radiography or X-ray inspection. Many times or sometimes a counterfeit component will have a die, we're talking integrated circuits now, the size of the die will be different than an authentic part, or the lead frame will be different. And so those are things that you can detect with an X-ray inspection. And again, whenever possible, compare to a known good authentic part. Electrical testing, that is very important. It's possible that you have parts that are not black topped, perhaps they look very good and are authentic, but it could be that they've been damaged from improper handling. Electrostatic damage could be an issue. It could be that these are a different clock speed or different voltage rating. There could be a number of issues where that part functionally, the basic function of that part could resemble an authentic part, but it has been either degraded slightly or it is functionally dissimilar to a slight degree. And the only way you would determine that is through thorough functional testing. But there's a whole spectrum of electrical testing you can do, from basic DC testing, just verifying that the part is alive, to full functional testing at a specific clock frequency and also at temperature. So, and when you get into functional testing, that's where you can really incur a lot of expense. Yes?
How do you deal with just a portion of a lot being counterfeit, potentially from a broker who your supplier has procured from previously? And even to the extent of, you talked about degraded functionality, you use it in 2 different applications, and one you see no failures, and the other you see extremely high. So when and they are mixed in with the OCM parts, so not everything in your bag is counterfeit. So you got a lot of different things going against you to make it harder to find that money.
Right. Okay, so the question is, what do you do if you have a lot that you've procured from a broker, and you detect that within that lot there are some counterfeits that, that you are able to prove are counterfeits, the rest of the lot may be authentic, okay? And that's not unusual for counterfeits to salt a lot, okay? And they may even put the authentics parts on the front end of a reel, okay, where you have a tape and reel of parts, and they'll put the authentics at the beginning, because where do most people pull their sample? From a tape and reel package from the beginning, usually. And so that's not unusual. But let's say that you're very thorough in your sampling, and you pick from various parts of the reel, and you pick up on the deceptiveness of that counterfeiter. What do? Well, I recommend that that entire lot be quarantined and dealt with, and that the broker be liable for that entire lot, okay? Because at that point in time, now you are dealing with a deceptive practice. Now, it could be your broker is the victim of someone further down in the supply chain, if you will. That is something that is going to have to be dealt with as you report this, this counterfeit event to the authorities. So with this legislation, it's now incumbent upon you as a defense contractor to report this finding of counterfeits. That entire lot becomes quarantined and becomes subject to removal from the supply chain. So that's how that should be dealt with. Yes?
There is a standard called aerospace risk mitigation plan. Maybe they should look into that.
Yes. Can you state that again?
There's a risk mitigation plan for the aerospace specifications, how to control the suppliers.
Okay. So the question is, how does the aerospace specification control the supplier? That's the question. Okay. Right now we have this legislation that governs everything concerning the DoD. Now, within the aerospace community, DoD and non-DoD, there are publications that are out, and I found several of those. And this is a concern for the aerospace corporation, or the aerospace industry, excuse me. And I can't speak to it authoritatively how they're going to deal with that on a aerospace component-wide situation. But this is what we have to work with from DoD electronic component counterfeit. I think that is still emerging. And I think the aerospace industry is dealing with it. But since I'm not embedded in the aerospace industry specifically, I can't comment authoritatively. Thank you for the question, though. Great. Okay, so, X-ray fluorescence, and I would also add energy dispersive spectroscopy to verify lead finish, inadequate finish, or incorrect finish. Okay, any of these could be considered evidence of counterfeiting. It is possible that a counterfeiter has taken a RoHS part, which RoHS would be something that does not contain lead and a variety of prohibited materials, and is representing it as something other than that. Okay, through X-ray fluorescence, you can conclusively determine what the lead finish is and compare that against your requirements, against the part number, and verify you are getting what you are supposed to be getting. So lead finish can be a big area where counterfeiters misrepresent what they are delivering to you and giving you something you didn't expect. It is also possible, and we have seen this, where a counterfeiter will actually take a part that is with a lead finish that is not what you want. He understands that you want something different, so they will then go in and replate those leads to give you what you desire. Well, that is counterfeiting. Okay, they are misrepresenting that part because the original component manufacturer has a unique part number, or in their original component offering that had a different lead finish altogether, and altering that part is part of counterfeiting and is misrepresenting that product.
Now, you mentioned Lowe's there. I ran across a gun supposedly that you could take and shoot your product, and it'll tell you if you're ROS compliant or not.
Yeah, it's a great question. There are handheld X-ray XRFs, okay? Now, the spot size of the handhelds, I'm not exactly sure how small of a spot size you can get. So I know on larger items they can be very effective. Does anybody have any experience with a very small spot size with a handheld XRF? Okay.
If I'm right, we use, I don't know if we use 1 millimeter or 0.4 millimeter, I'm not sure we use the
So if you're considering using a handheld XRF, I would recommend that you understand the limitations of that device, because you may be dealing with a component lead that is too small for the detection capability. You may get inconclusive or erroneous results. There are benchtop XRFs. They're very effective and can really get down to very small spot size and are suitable for very modern electronic components, fine pitch leads. And then you can also use the energy dispersive spectrometer that is a feature in the scanning electron microscope if you're really challenged with spot size. And there you can go very high magnification, very small spot size, and generate an elemental spectrum that'll tell you what elements are present in that lead finish or package finish. Great question. Great question. Thank you. Here are some other standard practices. Resistance to solvents. And earlier I referred to blacktopping and remarking. Now the counterfeiters are becoming more sophisticated with their blacktopping and remarking techniques. They're getting better and better inks and blacktopping materials. But we have a variety of solvents that we can use, and I won't get into details because eventually this information will be in public domain, and I do not want to give the counterfeiters exquisite detail on our methodologies for detection. But let's just say that, that we can subject that suspect part or unproven part to a variety of solvents, and the original component manufacturer's inks and finishes will hold up to those solvents, okay? Unless you're dealing with a, a substandard component manufacturer, that is. And that is a very basic way of determining whether a part's been altered through blacktopping or marking, remarking. So, and I'll show you an example of that in our case histories. Internal inspection, if you have a component that is a cavity device, we can essentially delid that, pop the lid and look inside. We can look at die markings in the case of an integrated circuit. Die markings will have usually the company logo and a specific part number or die marking that can be referenced back and authenticated as an authentic OCM die. So just general internal inspection is recommended. So those are the basic techniques. Some more advanced techniques, and these are techniques that we deploy in our lab at Exelis. We also use scanning acoustic microscopy. Now that gets you a lot, that gains you a lot of the information you would get in an X-ray inspection. This is a non-destructive test. You can see things such as lead frame, die size, etc. But you can also see evidence of remarking. If a part has been sanded and then blacktop applied, we may be able to pick up on that with the CSAM or the SAM. Also, if during the part removal process, let's say that is a counterfeit component and extreme heat was used to remove it from the scrap circuit board from which it was taken, there is some likelihood that internal delaminations have occurred. And we have seen that numerous times where we have been asked to look at potentially counterfeited parts. Because we do this work for a variety of defense contractors. So, we've been exposed to different occurrences of counterfeiting. Anyway, if there is there are delaminations internally, we will detect that with the scanning acoustic microscope. So we really like that method because it is very effective in not only determining whether die size is different and lead frame is different, but has a part been damaged through heat or some other harsh use. I mentioned EDS. We can use that to verify lead finish if XRF is inconclusive. And scanning electron microscopy to determine the presence or absence of blacktop if optical inspection is inconclusive. So sometimes an optical microscope it's just tough to see the detail you need to see. And SEM is very effective. Fourier transform infrared spectroscopy, FTIR. We can distinguish between the bulk package material used on an integrated circuit versus what may be the blacktop material. We'll get a different FTIR signature. And then functional testing. I mentioned before, sky's the limit on what you can spend for functional testing, and that's really where the economics of your program, the requirements of your customer come into play. What level of scrutiny do you need to have? Because you could go through burn-in, you could go through a complete DPA, you could really do a lot to gain that little extra measure of assurance as to whether a part is authentic or whether it's been altered or counterfeited. So it really comes down to an organizational decision at that point. Here are a few case histories. So now we're getting into the gory details of what happens in the bowels of the lab here. So this is the stuff I live for. Yeah, it's kind of twisted, isn't it? So this is a case history on an FPGA that we found electrical opens on this part, and it was caught early on, and I won't say it was our part, but again we change all the names to protect the innocent, right? Since we do work for a number of companies, I will not make reference to any customer of ours. I'll just say we found it happened in this part, and we won't reference any customer whatsoever. Anyway, we found that it was an old date code, which is kind of a red flag, okay? Whenever you see an old date code, and it's coming through the supply chain, it's possible that that lot has a storied history. Perhaps it's bounced around from broker to distributor. Perhaps it's been reclaimed from scrap electronics. So anytime you see a very old date code coming into your supply chain, that should be a red flag. And so the engineers came to us and said, hey, these parts are open. Can you tell us what's going on? Well, we performed scanning acoustic microscopy, and one of the first things we found was significant delamination or popcorning in different sized die. So compare this die to that die, and so we had a mixed bag of damaged parts. So even amongst the counterfeited parts, there were different varieties. Okay, 615 boards. The extent of this problem was pretty large for that particular product line. 19 boards were found that contained delaminated parts. Okay, and so this finding kicked off the 615 board screening process. Now let's get into some more details. So these were our initial findings, were delamination on this integrated circuit, which is a huge reliability concern because anytime you have a plastic package delaminating from a lead frame or a die, that can pull bond wires, cause electrical opens. So at this point, we surmised that it was highly likely that this popcorning caused the opens and opened up the internal bond wires on the integrated circuit. I'm going to show you another case history. So this was a pulse width modulator controller integrated circuit. The symptom was it did not function correctly in a circuit without adjacent component value changes. So the gentleman earlier who described a lot of material where some parts worked in the circuit, some did not. In this case, we had a lot that worked correctly, and then we procured another lot. Now all of a sudden that lot did not function correctly in the circuit. So the question was, what is different? And the engineers were able to get that component to function in the circuit, but they had to change adjacent component values. So this is the suspect component, top view and bottom view. And it was in the background is this was a mature program that was in the life cycle where now we had to procure obsolete components. Could not get those parts through the OCM or the authorized distributor, but it was purchased from a reputable broker with whom we had done a lot of business. When I say we, the customer for whom our lab performed the surface. Okay, this does not mean this is an Exelis problem, by the way. The newly purchased broker supplied parts that could be made to work in the circuit only by changing some passive components adjacently. So when we performed scanning acoustic microscopy, we found quite a bit of delamination on the die paddle and on the die attach. So this is the die paddle delam. This red area is the delamination. When the acoustic energy travels through the part and hits an air gap caused by delamination, nearly 100% of the energy is reflected back. It gives us this signature. And then we can focus on different areas within the part, and the die attach is shown over there. That has delamination as well. And this sort of delamination is indicative of excessive heating. Now, it did not see this excessive heating in the circuit, so we presume that it saw it during the counterfeiting process. Now, we didn't make that assumption until further on in the analysis, so I'm kind of getting ahead of myself here. So we did some more inspection, and if you look at the close view top image, you can see where the laser markings are a little bit off, okay? And you can see some ghosting from previous markings. Can you see that? Now the right-hand image is a surface scan, a scanning acoustic microscope image where we're focusing on the very top surface of the external package. And you can see these linear features going diagonally. Those are sanding marks that the counterfeiters left behind underneath the blacktop. So your visual inspection may or may not have picked up on this marking ghosting here, and they certainly would not have picked up on the sanding marks, but the scanning acoustic microscope inspection did. Now, recall that what were the markings? Markings were Texas Instrument. Here's the logo for TI. The great state of Texas, broadly or proudly exhibited there. But then when we went through a decap process where we dissolved the plastic package to look inside, this is what we found. This is what an IC die looks like. These are bond wires. But when we focus on the part markings, we're looking at this area here in greater detail here. That is not a Texas Instrument part, is it? It's made by Micrel. And so the counterfeiters took a Micrel part, sanded off the markings, and then relabeled it as a Texas Instrument part. So this is an actual case history from our lab. And here's one last case history where there were some circuit boards that were where the contract manufacturer did not handle a certain component correctly. It was a moisture-sensitive part, and they did not handle it in a prescribed way for that type of moisture-sensitive part. So the OEM, okay, the contractor who subcontracted the board builder found out about that, and he says, whoa, we need to make sure that these parts have not been damaged. And the typical damage that results from moisture-sensitive part going through a soldering process is popcorning or delamination. So we were asked to look for evidence of delamination. Counterfeiting was not even suspected at this point. Now, during a cursory inspection, we found evidence of blacktopping, and that's what we're going to show next. So samples had different styles of marking. Now you notice that the date code is the same, but the style of marking is different. So this is an example of paying close attention to the marking. And this is a blacktop layer. You're looking at a IC from a side view, and this glossy coating is blacktop, and this is what the package material should look like. Should have this basically the same finish. So that tipped us off that there was a blacktop issue. Now, we then took the part and subjected it to marking permanency testing. You know, we applied the solvents, and essentially we removed the blacktopping with that solvent. And underneath where the blacktop was, you can see sanding marks. And that's what we have for counterfeits. It is 8 o'clock. Now I'm available if you have any questions, if you want to talk about failure analysis. You're under no obligations to stick around, but anybody have any questions?
Did you find top pointing in that last example?
In that particular example, we did not. We did not. Yeah, good question. So their soldering process did not cause popcorning, but we did find counterfeits. Any questions?
Getting back to the strategy, you've got a finite number of lots of something coming in, and there are a lot of them. And you've done a random sample, and you've determined that there are counterfeits in these lots, but there's a lot of money invested in it. I mean, how do you identify the good from the bad, or is there a strategy for that?
Yeah, great question. Now, if you have a lot with good and bad in it, we would say that lot needs to be quarantined and removed from the supply chain. And the new legislation states that.
Okay, so there's no chance to retrieve it at all?
I would say not, you know, unless my understanding of legislation is incorrect. Okay. Well, thank you so much, everybody. Thank you.
Thank you very much.
You're welcome.
As
Thank you.
always.
Oh, yeah. Working out the love in high school now. Got away from that girl and
First, the last time you were here, I think it was in November. And,
Yeah, Tom.
This is a really great follow-up.
Well, thank you, Tom.
Fascinating kind of work. It's like being a CSI is what it amounts to, right?
It really does. It really does. Absolutely. So who do you work for, Tom?
Well, I work at the university. I do teaching. I do Lean Six Sigma training and consulting on the side as well as at the university. So I have all my students doing real interesting kinds of projects for the clients.
Oh, wonderful.
I enjoy it.
That's great. And you've been teaching for how long?
For about 4 years.
4 years. Fantastic. This is Derek Smith.
I work there. Nice to meet you, Tom. Nice to meet you.
And who do you work with?
I work with IUPUI as a Lean Six Sigma consultant.
Oh, fantastic.
I teach graduate level Lean Six Sigma principles. Both full-time people like ourselves that come back for their graduate degrees, and then also full-time students.
We've
Fantastic.
got quite a culture of Lean Six Sigma Black Belt program within Exelis.
Great.
Or ITT.
That's great.
Yeah.
Yeah, I'm familiar with ITT Corporation, so Exelis is part of that.
Yeah. They broke into 3 pieces last October. Defense went to Exelis.
Okay.
Thank you so much.
Excuse me. I was in the computer business in the 90s.